Welcome to this Landwise presentation on soil water budgets for irrigation operators and crop managers. Any budget involves comparing inputs and outputs and making sure you expect to stay within some limits. Think of it like keeping tabs on your vehicle's fuel reserves. Soil moisture measurement shows the actual amount in the tank. If you're planning to drive somewhere, you'll look at how much is in the tank. Think about how much fuel you expect to use per 100 kilometres and estimate if you have enough. If you don't, you plan to put in some more. But you can't put more in the tank than what it holds, or you get a lot of runoff. So you might need 120 litres to drive to a distant city, but if your tank only holds 60 litres, you'll have to fill up at least twice. It's in the same way that if you expect to need 70 millimetres of irrigation to last 2 weeks, but your soil only holds 40 millimetres, you'll have to apply it in a couple of irrigations. Evapotranspiration, or ET, is the water loss from leaf transpiration and soil evaporation. It is measured like rain in millimetres. ET is like negative rain. Potential evapotranspiration, or PET, is the amount of water that would be lost by well-watered, well-fed, healthy grass like a lawn at a research station. The crop factor accounts for different species transpiring at different rates, and for the amount of ground covered at the crop. In general, bare soil loses water at roughly half the rate that watered plants do. The crop ET is calculated by multiplying the PET by the relevant crop factor, which for most crops changes during the season. Effective rainfall only includes that which can be stored in the crop's root zone. If there is a lot of rain or irrigation, or both, much of the water that lands will be lost through drainage or runoff. As the crop's roots grow deeper, the amount of soil it can get water from increases. Budgets change as crops develop and as the weather changes. What are the ins and outs for a soil water budget? The inputs we can measure are irrigation and rainfall, both in millimetres. We can also estimate our outputs from our PET figures and crop adjustments. We do the maths and try to keep the soil moisture between field capacity and stress point, or refill point as it is sometimes called. We calculate wasted water via runoff and deep percolation in our budget, as this is how we account for the excess we applied that put the soil moisture over field capacity, the litres of fuel we spilt across our forecourt. We can't do much about many of the other factors such as capillary rise and subsurface flow, so we usually ignore them. Most of the times we'll be alright doing this, as if we have flowing springs and upwelling water tables, maybe we don't need to irrigate then anyway. This table shows likely crop factors for a range of crops grown in New Zealand. These were prepared by Dr. Tony Davern and are based on thousands of actual soil moisture measurements made in crops across New Zealand over many years. They give a good guide for estimating likely water use, but you should still measure the soil moisture to keep a check on what is actually in the tank. Let's look at irrigation for a bean crop as an example. Let's say your weather station or published information tells you the potential evapotranspiration tomorrow will be 4 millimetres. But you're not growing grass, you're growing a crop of beans. You check and find that the plants cover 40% of the ground area, so you adjust the PET figure accordingly. In this case, 4 millimetres times 0.4 means you'll use about 1.6 millimetres of water tomorrow. Notice that different crops, potatoes and lucerne, can have different crop factors for the same ground cover percentage. This is an example budget. So we are tracking inputs in blue, outputs in brown, and the difference in this green and the balance in sort of the pinky colour, and of course we have the date. So inputs are added up as our total deposits, and our outputs are added up as our total withdrawals. So in this example we're using a fully developed crop, so we have a crop factor of 1. So we take our PET times that by 1, which gives us our millimetres of evapotranspiration. If we have a look at this budget, we can see that we haven't put in any irrigation or any rain between the 1st of January and the 4th, but we have, of course, had withdrawals as our plants have been growing. So each day we have seen that our budget has dropped by the amount of evapotranspiration that we've had for that day. On the 5th of January, we decided to apply some irrigation water. So we added 20 millimetres. However, we had a withdrawal of 4 millimetres, so our total addition is only 16 millimetres. However, this has brought us back up to 48.5 millimetres, which is almost back at our total balance and full field capacity. If we look down here on the 9th and 10th, we've had 2 days of 15 millimetres of rainfall. We're going to claim that we're really good at scheduling, and when we applied our 20 millimetres, we knew that we were going to get this rainfall in a few days' time. So we were waiting for that rainfall before we decided to irrigate. So we haven't irrigated any further after the 5th of January. After we've had that 15 millimetres on the 9th, that has brought us back up to pretty much field capacity at 47.5. So our second lot of 15 millimetres that falls on the 10th of January, we can see that we're actually sitting at 61.5. Therefore, we have more water supposedly sitting in the soil than the soil can handle because field capacity is 50 millimetres. Therefore, we've had 11.5 millimetres of drainage and or surface runoff. That brings us back to a balance of 50. And then it continues on, tracking our inputs and our outputs and maintaining that balance.